My name is Brian Schwartz, and my project is Forest Fire Simulator using Cellular Automata is superior to simple formula-based wildfire simulator. I'm an Eagle Scout, and I'm interested in forest fire simulators because this past summer I was unable to go on a Philmont backpacking trip with my fellow scouts in a scout ranch in New Mexico. I was unable to go to the rampant forest fires that have been occurring in that area, and this is very interesting because that area is heterogeneous. This is due to the multiple different kinds of structures, roads, campsites, and forests that are in the same scout ranch. This is very peculiar because there are the current firefighting techniques with simulators are for homogeneous environments. This is for the pine-rich forest of North America as one example. The most common one being used is Farsight. Farsight is a homogeneous simulator that is specifically good for modeling in North America, but is used worldwide and is the gold standard for homogeneous modeling. As a result, I wrote a Cellular Automata simulator to test to see if that would function better in a homogeneous environment. I chose a homogeneous environment because currently Cellular Automata simulators have been shown to work more effectively in a heterogeneous environment. To summarize, current simulators are very effective in homogeneous environments, but due to the increase of heterogeneousness around the world, these simulators are becoming less effective. So I programmed a Cellular Automata simulator to test if it's an effective model for modeling forest fires. There are 60,000 to 80,000 wildfires that occur in the United States each year. This equals 3 to 10 million acres being destroyed. Recently in California, there were 44 deaths from one forest fire alone. This was in a heterogeneous environment where this is actually going to be even more heterogeneous as the cities are sprawling out into the forest. Forest fire simulators are especially important because they decrease the risk, they aid in suppression, they protect the people, and prevent the spreading of wildfires. The purpose of this project was to test the wildfire formula-based simulator versus the Cellular Automata simulator. These two simulators were chosen as they are the most common methods of simulating forest fires. The formula-based simulators were created in 1946 for the use of for fighting forest fires, and it's the most common method of forest fire fighting. This includes Farsight, which, as I said, is the most common used for forest fire simulator. The Cellular Automata simulators were created in 1940, and they are a mathematical model of a grid that changes over time. Each point on the grid has a finite number of states that change each generation. This is a very computer-intensive method and is only being shown to be used more effectively now. The hypothesis of this experiment was that if the Cellular Automata simulator and formula-based simulator are tested, then the total quantity of areas burned by the Cellular Automata simulator will be closer to the total amount of area actually burned. Currently, research is being done on Cellular Automata simulators in both Southern Europe and China to test the simulator in a heterogeneous environment, where it's been found that Cellular Automatas simulators are effective in a heterogeneous environment. Yet, since this study is homogeneous, the purpose of this study is to test if the Cellular Automata simulators can be used universally in both homo and heterogeneous environments. The simulators used for this project is the Farsight, which is the gold standard for a homogeneous environment, and so is thus used as the control. The Wildfire Simulator, which is a formula-based simulator, and my own Cellular Automata simulator. In order to do this project, I wrote a C++ model of a Cellular Automata simulator that had a fire grow based off 3 probabilities of ignition: height, moisture, and vegetation, and the fire would grow incrementally. Next, I had to calibrate the simulation using the same data that is used in the Farsight model, and the wind speeds were tested throughout the testing process at 0, 5, 10, 15, and 20 miles per hour. Each data point went for 6 hours and was put into Excel for testing, where the t-test value was set at 0.01. In comparison, the wildfire simulator, as seen in red, was statistically significantly greater than the Farsight and the Cellular Automata simulator, as seen in blue and green. This remains evident in the 0, 10, 15, and 15 wind speeds. Meanwhile, in the 5 mile per hour wind speed, the wildfire simulator approaches statistical significance, yet it does not reach statistical significance in comparison to the Farsight and Cellular Automata simulation. In the 20 mile per hour wind speed, all the simulations recorded almost the exact same amount of total area burned, and there was no statistical significance. When looking at the combined data, it is evident to see that between the Cellular Automata simulator and the Farsight simulator, there was virtually no difference between the total amount of area burned. But between the Wildfire simulator and the Cellular Automata simulator and the Wildfire simulator and between the Farsight simulator, there was a statistically significant difference throughout the entirety of the data set. There were a few limitations to this project. First of all, it was in a very simple and homogeneous environment. There was limited fuel supplies that could be tested by the Cellular Automata simulator, and the wind was homogeneous in both its direction and its velocity. And time and computing power that Cellular Automata simulator uses was not taken into account. In the future, I hope to be able to compare this data to historic data, for example in California, where more and more fires are occurring, and to test more complex wind changes with velocity and over distance. In conclusion, there was no statistically significant difference between the Cellular Automata simulator and the Farsight simulator. The hypothesis was supported that my own Cellular Automata simulator is superior to the simple formula-based wildfire simulator, and this means that Cellular Automata simulators can be used as a universal method of simulating wildfires, which can aid in firefighting efforts around the world. Thank you for your time. Do you have any questions?